Okay, we are in section 11.6. 11.6 is titled Volume of Prisms and Cylinders. That's an I. Okay, first of all, what is volume? The volume of a solid is the number of cubic units contained in its interior. Volume is measured in cubic units, such as cubic centimeters, cubic feet, cubic inches, cubic millimeters, cubic anything of length. We have a few postulates. Postulate 27 is volume of a cube. Okay, a cube, all the sides are the same length, so the volume of a cube is the cube of the length of its sides. So all of these are S. Every single edge is an S. So if we did the volume, it would be length times width times height. S times S times S, which is S cubed. Postulate 28, the volume congruence postulate. If two polyhedra are congruent, that means if all of their sides are the same measurement, then they have the same volume. Duh. And volume addition postulate. The volume of a solid is the sum, the addition of all of its volumes of all of its non-overlapping parts. Basically, that means that we can cut any three-dimensional piece into smaller pieces to help us do the volume. Okay, so I could cut this top off, find the volume of that, this, find the volume of that, add them together, and I have the volume of the whole thing. And let's try that. Find the volume of the puzzle piece in cubic units. There's a few ways we can do this. Okay, we can find the volume of three different pieces, which I would cut this one right here, cut that one right there. So I'd have piece 1, piece 2, and piece 3. Okay, if we look, the volume of piece 1 is 2 units times 2 units times 1 unit. 4. The volume of piece 2 is 1, 2, 3, 4, 5, 6, 7 units times 2 units times 1 unit. 14. And the volume of piece 3 is 1 unit times 2 units times 1 unit. If I add those together, 4 plus 14 is 28 plus 2 is, 4 plus 14 is 28 plus 2 is 30. 20, oh my gosh. I should rewind that, but hopefully you guys will get a little kick out of it. 4 plus 14 plus 2 is in fact 20 units cubed. Okay, with this type of shape, you could also just count the units. I've got 1, 2, 3, 4, 5, 6, 7, and in the back, the same amount, so that's 14. 1, 2, 3, 4, 5, 6, 7. Over here I have 1, 2, 3, 4, so 7, 8, 9, 10, 11, 12, 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you can count each little cube as it's sitting there, and you'll still get 20 cubic units. Okay, 2 theorems. The volume formulas. The volume of any right prism or right cylinder can be found by multiplying the area of its base by its height. So if we multiply the area of this two-dimensional figure, find the area of this little, I'd say it's a rectangle, and multiply it by its height, that'll give you 3 dimensions, which is, it's almost like you're stacking a whole bunch of these little pieces of paper up on top of each other until you get a full box. So the area of whatever two-dimensional piece you can find times the height, or what we learned, length times width times height. I put a D. Wow. Where this right here is the area times the height, which is volume. And here, the base is a circle. So we get pi r squared, which is the area times the height. Area times the height. So basically, volume of a cylinder is right here, and volume of a prism is right there. So remember those two things. Let's try one. A right cylinder. Volume equals area of a circle times its height. The radius is 9. The height is 6. So we have pi times 81 times 6. 1,526.8 feet cubed. Alright, let's do some algebra with that. The volume of this cube is given. Find the value of x. Remember, volume of a cube is s squared. Ha, cubed. One of those days. So the volume of a cube is s cubed. If we know the volume, then you can take the cubed root of both sides. Now if you're in a graphing calculator, you're going to push the math button and look for this symbol. And hit enter. Okay, if you're in a regular calculator, let me get one out. Sorry about that. You're going to look for a button that looks like this. Let me draw one for you. So a regular calculator, you're going to look for a button that looks like this. And what you're going to want to type in is cubed, just the 3, then the button, and then 90. Okay, that 3 goes right there, so you know how to do it. So once you try that, your answer is going to be 4.5 is x. Okay, please ask me tomorrow if you're not sure how to use your calculator. I would love to show you how. Okay, find the volume of the puzzle piece shown in cubic units. Okay, this is a you try, so I'm going to push pause and you're going to try this one on your own. Okay, I cut it into 2 pieces. One piece, it's just 1 by 1 by 1, so I multiplied those, and the cubic, or the volume of that is 1 units cubed. Okay, the other piece, once I cut the square off of it, I got the height is 2, the width is 3, and the depth is 1, so 2 times 3 times 1 is 6. I added 1 plus 6 and got 7 units cubed. Find the volume of a square prism that has a base edge length of 5 feet and a height of 12. So if I draw a really rough sketch, it's a square prism. That means that its base is a square. So 5, 5, and 12. I'm pushing pause. You give me the volume. Sorry about that. 5 times 5 times 12, so the area of the square is 5 times 5, or 25. 25 times 12 is 300. Find the volume of a right cylinder, the volume of a right cylinder is 684 cubic inches, and the height is 18. Find the radius. Volume equals area of a circle times height. Okay, push pause and try this one on your own. It's a tiny bit tricky, so just make sure you know how to do it. Okay, the radius is 6.2 inches. First I set up the equation. Volume equals area of a circle times height. Divided both sides by pi and 18. I should cross that out. Divided the left-hand side by pi and 18. So 684 divided by 18 is 38. Square root of both sides are 6.2. Alright, Cavaliere's principle. Consider the solids below. All 3 have equal heights, h, and equal cross-sectional areas, b. Mathematician Bonaventura Cavaliere claimed that all 3 solids have the same volume. The principle is stated below. If two solids have the same height and the same cross-sectional area at every level, then they have the same volume. It doesn't matter if it's a right prism, where the height and the base would be a right angle, or if it's slanted, or they call it oblique. The shapes have the same volume. Find the volume of the oblique cylinder. So the volume of a cylinder is area of a circle times height. The radius is 4, the height is 7. Pi times 16 times 7 is 351.9 centimeters cubed. Okay, the planter is made up of 13 beams. In centimeters, suppose the dimensions of each beam are 30 by 30 by 90. Find its volume. The easiest way to do this one is to find the volume of the entire shape, from the outside, the whole thing. So find the whole volume. And then take away the blank spots. Does that make sense? So I'm going to find the volume of the entire piece, the full length times width times height, what I'm coloring in. I'm going to find the whole volume, and then I'm going to take away, cut out the volume of the missing pieces. Okay, so let's try that. The volume of the whole thing would be 90 times 510 times, 30 by 30 by 90. So 30. This would be, this first 90 is right here. So that's this dimension times this dimension. And then the depth, which you can't read here, the depth is also 30. It says 30 by 30 by 90. Okay, so 90 times 510 times 30 is a big number. Now I'm going to find the volume of the opening. The volume of the opening would be 90 times 30 times 30. And there are 1, 2, 3, 4 of those openings. So I'm going to multiply that by 4. 90 times 30 times 30 times 4. Okay, if I take the volume of the entire thing and take away, cut out, subtract the volume of the openings, take away 324,000. I get 1,053,000 centimeters cubed. Okay, it doesn't tell you to change that, but if we divide by 1,000, that would give us 1,053 meters cubed, which is a much more reasonable answer. But they didn't tell us what units, so this answer is just fine. Okay? Okay, you try. Find the volume of the oblique prism shown, where we know area of a triangle is 1/2 base times height. So go ahead and push pause and try it on your own. Okay, area of a triangle is 1/2 base times height. Volume of this triangular prism is 1/2 base times height times height. And there's our answer. Find the volume of the solid shown below. Here, again, we would have to find the volume of the triangular prism and take away, or cut out, or subtract the volume of the square prism, which would be base length times width times height. Okay, go ahead and try it, see what you come up with. This triangle is an equilateral triangle, which you guys know how to find the area of. We did it last chapter, so go ahead and try on your own. Okay, let's talk through this one. First, I had to find the area of the triangle. It's an equilateral triangle, so the area is 1/2 the base, or 1/2 base times height. The height we don't know, but we do know if we drop an altitude from the vertex to the base, it cuts the base in half. So this piece is 5 and that piece is 5. So here I have a right triangle, and I can do the Pythagorean theorem. 5 squared plus x squared equals 10 squared right here. So x, the height, the altitude is 8.7. I'm going to use that. Volume equals 1/2 base times height times the height or the depth, this third unit of the triangular prism. So 1/2 base times height equals 261 feet cubed. Then I look at the volume of the square prism that I need to cut out. Okay, length times width times height equals 54. So I have the volume of the triangular prism, subtract the volume of the square prism, and I get an answer. Daily homework quiz. I have 3 pages. Page 1, page 2, and page 3 was empty. Good job. See you guys tomorrow.